The Big Bang represents the event from which the universe originated. This event occurred approximately 14 billion years ago. The Big Bang is characterized by a massive explosion. In the immediate aftermath, the universe existed in an extremely hot and dense state. During this early phase, light could not freely propagate due to the extreme conditions. As the early universe expanded and cooled, fundamental particles began to emerge. Photons, the elementary particles of light, were among the first particles to form. For hundreds of thousands of years, these photons remained trapped within a dense plasma. The trapped photons constantly interacted and collided with other particles. The cosmic microwave background, CMB, originated approximately 370,000 years after the Big Bang. At this time, the universe had cooled enough for atoms to form. The formation of atoms allowed photons to decouple from matter. Decoupled photons were then free to travel through space. The CMB represents the earliest light that is observable today. Star formation begins with gravity acting on matter in space. Gravity gradually pulls matter together, creating massive clouds of gas and dust. These clouds eventually collapse under their own gravitational force. The collapse leads to increased density and temperature at the core of the cloud. At a critical point, nuclear fusion reactions ignite at the core. The ignition of nuclear fusion marks the birth of a new star, emitting light and energy. The first stars emitted light that significantly impacted galaxy and planet formation. Radiation pressure from this starlight affected the distribution of matter in space. This influence shaped the large-scale structures of galaxies observed today. Massive stars ended their lives as supernova explosions. These explosions scattered heavy elements throughout the cosmos. This enriched the raw material available for future generations of stars and planets. The Sun, a star formed billions of years after the Big Bang, is essential for life on Earth. Nuclear fusion in the Sun's core produces light and heat. This energy supports photosynthesis, climate regulation, and biological processes. The sunlight we experience originates from these fundamental processes.